I think one of these days when we should all do the countdown together, and then at the end we all just scream. And that way, anybody watching the video, we'll wait till let's wait till a day when there's like 3 or 4, like a bunch of people gone, like there's a field trip, and then I say watch the video, and then we'll all just scream right at the beginning of the video. I know. Okay. So before we talk finding percentiles with z-scores, let's make sure we are clear. You should absolutely make a picture every time we're working with the normal model. Because, let's put that back. Because as we saw from yesterday when going with the 68, 95, 99.7 rule, it is very beneficial for us to see where the z-scores fall, where the standard deviations fall. It's also really helpful in answering a question to be able to highlight or shade in the area that we are trying to find, right? Because remember, everything we did yesterday with the normal model and the 68, 95, 99.7 rule, all of it had to do with areas. Because the area beneath this curve, this shaded blue space down here, right? All of this area, when you add it up from negative infinity to positive infinity, adds up to 100%. And so all we were doing yesterday with that 68, 95, 99.7 rule was seeing what the area underneath the normal curve, what it is. All right? We were just finding areas, and that's the general rule is one standard deviation, this space, the area beneath the curve in here is 68, it's 0.68. 2 standard deviations, the area beneath the curve is 0.95. 3 standard deviations, the area is 0.997. Okay, and as you go further out, that gets closer and closer to 100. So making that picture so that you're able to see that is a really important thing. It also, on the AP test, that counts as showing your work, right? When you draw the picture and shade in the appropriate area on those types of questions, that counts as showing your work, and you won't lose points, right? Because on the AP test, on the free response areas, if you don't show your work for something, you automatically are going to lose a point, right? Every free response question is 4 points, and if you don't show your work, the most you can get on a problem is 3 points. If you don't explain your answer, the most you can get is 2 points, right? So you've got to do these showing your work, writing sentences to explain the number. It's really important. So we make histograms. We make sure that the data we're working with is nearly normal. Because if our data is not nearly normal, we cannot use any of these methods. We can't use the 68, 95, 99.7 rule. And we can't do anything with z-scores. So let's do some z-scores thing. You guys don't happen to have your books with you, do you? I didn't tell you to bring it. Does anybody bring their book today? Okay, if you got a book, you might share it with a person next to you. Nobody in the back table over there raised their hand if they have it. Oh, Ty's got his. Kelsey, or probably Kelsey, do you want to grab the teacher's edition right there that's on my workstation? And then you guys can take a look at it. I want to show you guys something, and I'm mostly just showing you to give you appreciation for what your calculators can do for you now. Because in the olden days, this is how we had to do this work. When I took a statistics class, my college professor was he wasn't anti-technology, but he was very stuck in his ways when it came to how you do some of this work. And so he would only show us how to do the 1920s way of this problem. And so this is how I learned it. Later, I learned how to do it on my calculator. And that's what I'm going to show you guys today, too. And in all honesty, I don't know if I've ever really expect you to do it this way. It's one of those things that, I'm telling you because just in case, you get stranded on a desert island with a statistics book and you have to do some statistical analysis for some reason, right? You're trying to figure out, you found that the number of coconuts on the island is normally distributed, and you're trying to figure out what the top 95% of the Yeah, it's like Hunger Games but with statistics. Yeah, that's. If you're ever in a situation like that, it would be good to be able to use the normal model tables because your calculator got lost in a plane crash. Because for some reason, wherever you were going over the ocean, calculator. It's a really very specific instance when you would use this. Back in the back of your book, go to table. It's the Z table. It's in Appendix D. It's like the last couple of pages in your book. It looks like it's like the very, very back. Like the last, not like that far back. But the last couple pages under the. Yeah, that's it right there. It looks like a big table. It looks like some vomited numbers on that page. And I think you want the one that says appendix D. Yeah? Okay, so my slide is wrong. It's appendix G. So if you're looking for exact percentiles, right? Yesterday we did, it was, when you had two standard deviations that approximated to this. If we needed something exact, so let's say we needed to find what the percentile is for a z-score of 1.8, okay? What you do is you go to this table, and on the left-hand side, you find 1.8, and then on the top, there's 0.00, 0.01, 0.02. 1.80 would be 1.800. That's the percentile. On the left-hand side, there should be numbers from like 0 to 3. And on the top, there should be numbers 0.00 to like 0.09. So if we're looking for the z-score for 1.8, we'd go to 1.8 on the left and 0.00 on the top, and where they intersect would be that number, right? Before they had calculators, this is how they had to calculate these things, right? Somebody went through and actually did the integral of everything, right? And Jared's the only person who knows what an integral is, but that's okay, right? Somebody went through and did the integral of all these things, and they said, instead of having to recalculate the integral every time we know something, why don't we make a table of like 100 different integrals, and then we don't have to do it all the time. So that's what they did. So that's how they got to 1.8, right? If we wanted to find 1.65, you're going to go to the area here that says 1.6, and you're going to go over to where it says 1.05, or 0.05, and that's going to be 1.65. Hi, Lizzie! Hi! Can you guys look that up? What's 1.65? Somebody look at your table and tell us what 1.65 is. So 1.6 would be here, and then the 5 is what's along the top. So you're going 1.6 on the left, 0.05 on the top, and you're finding where those two things intersect. You guys got it? What is it? Is that right? 0.9505. Now the thing to be careful of these tables, and what your calculator is doing as well, the 68, 95, 99.7 rule is calculating a distance from here to here. This z-score of 1.65 is calculating it from 1.65, which is about there, and it's doing everything to the left. Notice the shaded region on this picture? 68, 95, 99.7 does the middle 68%, the middle 95%, etc. These tables and what your calculator does is going to take that spot on your z-score and do everything to the left. Okay? Not the middle. Everything to the left, to infinity. Were we able to find the 0.9505? Other groups with books? We're okay? Kind of get how this works? It's not terribly difficult to do. It's just a pain in the butt, right? Why would we ever want to do this? The good thing is I'm going to show you guys how to do it on your calculator because it is so much nicer on your calculator than it is here, okay? So let's use technology now. I'm going to back out of this. We're going to discard those. And we're going to go to the TI calculator. You guys want to get your calculators out? Why did that disappear? Yeah. There we go. What's that? The teacher's edition and yours. At the back of the book, the teacher's edition has every answer, and the student's edition only has the odds. Literally the only difference between the two books. Yeah. Take it with you. Okay. Let's find a couple of. I'm gonna write down a couple numbers, like negative 1.65 and 1.5 and like 2.7. Let's just use those ones to find our thing here. I'm going to run back. If you're watching the video at home, Brittany, it's pretty easy. You're not going to hear it. Probably didn't hear that. I'm not talking to you. No, it's that little black thing in front of it. I want to get a lapel knife. Let's press the button. So, what we need to do, once we know what our z-score is, we're going to use a command under the distribution menu. So it's this command right here, DIS. So we hit second bar. And notice that over here in this menu, there are a variety of commands. All of them are different distributions. Notice that you've got a normal distribution here that says normal. There's also says t. This I know looks like x squared, but it's actually chi-squared. We're going to use a bunch of these this year, but right now we're going to focus on the normal model. So if you look at these top two commands, you have normal PDF and normal CDF. The PDF stands for probability density function. And the CDF stands for cumulative density function. There's probability density function and there's cumulative density function. Later on in the year when we're doing other distributions, this is going to make a big difference which one you want to use. For now, and when we're talking about normal models in general, we always want to use the cumulative density function. So this normal CDF is the one that we're going to use. So you're going to want to pop down to CDF and start that. Now, if you have an 84 or above, when you do this, you're going to get this, I call it a wizard, right? You're going to get this wizard menu that is going to tell you what to type in. If you do not have an 84 or above, you just went back to the home screen and it says normal CDF, and then it's asking you to type in a couple of numbers. Okay, Courtney. It should be in your second bars, and you should be pressing enter on the normal CDF button. Yeah, so you have an older calculator, and you're going to have to type the numbers in manually. You don't get a wizard. So you have an older 84 is what it is, right? There's the TI, so there's TI-84s, there's TI-84 Plus, there's TI-84 Plus C Silver Edition. That's an 84 Plus, and it still doesn't come up. So you just have old, so you have an older software set on that right now. We might be able to plug that thing into the computer and update. I think it's firmware is the correct word for it, right? We might be able to update the firmware. How many others do you guys have an 84, but it's still not coming up with the wizard? Okay, so a couple of you. If one of you guys can maybe volunteer to come in after school at some point, we can test that theory. I think you can update the firmware. I don't know for sure. Maybe. Do you have the USB cable that you plug in? Maybe you can test it. Miss Huggins is actually coming in today, and she's going to bring in a cable so I can plug a calculator into the computer. So maybe I'll toy around with it today. I'll see you guys. So yeah, and then there's Aiden up here. He's got his, whatever it is. He's like pressing all kinds of buttons trying to figure out where it is. There's a menu for it somewhere.
I know. It's like I'm looking at one lens. What is a flash app?
What is a flash app? I don't even know.
It's like more apps.
What's up, Hannah? So PDF was probability density function, and CDF was cumulative density function. And we're always basically going to be using the CDF. So here's the deal, right? Remember that we're talking about a normal model here, and the whole point of this function, this calculator function, is that it is calculating the area underneath the normal curve. Notice that it says lower and upper, right? We have to enter two numbers in to make this work. The lower bound and the upper bound. So let's just say, for example, that we wanted to find this point right here, which we're going to call negative 1.5, and we wanted to find everything to the left of that, okay? Notice that that goes on forever and ever that direction. If it goes on forever and ever in that direction, what's my lower bound? Infinity, which that's pretty close to negative infinity. The reality here is, though, all you actually really need to punch in for this, because remember how close this gets to 0, and it's once you get out past like 4 standard deviations, it's really not changing that much. The max you ever really need to do here is negative 10. That's just put black dots on there instead of actually using the mouse. Let's try that again. The most you need to ever really do is negative 10. Let's do a little experiment here. Let's have you guys in the back. You guys in the back put in negative 10. You guys over here put in negative 5. You guys put in negative 4. You guys in the front put in negative 3. And let's just compare all of them. Okay. So lower bound is negative 10. Then we're going to go to upper bound. That's where we're going to put in the negative 1.5 because that's the upper place where we want it to stop. If you are putting these numbers in because you don't have the wizard, the first number you put in is going to be the lower. The second number you put in is going to be the upper. The third number you put in is going to be the mean. The fourth number you put in is going to be the standard deviation. However, you only need 2 numbers. If you're using it without the wizard, just do lower, comma, upper. So yours is going to look like normal CDF, negative 10, comma, negative 1.5, and then you'll press enter. Okay? Leave your mean and your standard deviation as 0 and 1. Go ahead and go down to press paste. And press enter. Notice when you do that, it puts normal CDF and those commands into the menu, which is exactly what Courtney and Justin and Joe are all looking at right now. You guys just had to put those numbers in. We got the wizard to put it in for. Press enter one more time, and it gives you your amount. Yours says error. I know. Oh. Yeah, probably. Okay, so the negative tens, I stole your guys' thunder. It was 0.0668, which, by the way, is 6.68%. Let's hear some of the lower ones that you guys did 5. Wayne, who did 5? What did you guys get? So at 5, we were accurate to 5 decimal places. What about at 4? At 4, we were as accurate up to 3 decimal places. At 3? Is that what you guys got to? So at 3, it was accurate to 2 decimal places. So notice that from negative 10 to negative 3, it didn't change a whole lot, right? So no matter what you use, I say negative 10 is good enough, right? If you leave it as that negative 1 times 10 to the 99th power, then you're going to get something just as accurate as negative 10. Your upper negative 1. So what your calculator just calculated for you was this section right here, right? From all the way to a negative infinity, all the way up to this negative 1.5. Okay? Questions, comments, concerns so far? That's looking at a normal model that has a mean of 0 and a standard deviation of 1. This 0, 1 is basically saying what normal model are you looking at? That's your z-score that you're inputting here, that your 1.5 standard deviations to the left of the mean. Kelsey? What's that? So this is our answer, right? If we're looking for the percentile, right? If we're saying like how many Dutchmen are less than negative 1.5 standard deviations below the mean, 6.68% of Dutchmen are lower than that. Right? Courtney? Those are the lower bounds. So basically what we're saying here is this is the upper bound. We're telling the calculator, take the area from here to here, right? Like imagine the normal model kept going that way. It kept getting closer and closer to the mean. It's calculating the area beneath this. And then the people who did negative 10, you just made a more accurate one as the normal model kept getting closer and closer. Yeah, absolutely. But you know what? You're going to get like the same answer as this right here. Do it right now. Type in negative 1 million. And we can see how accurate it's going to be. But I'm willing to bet that it's going to be basically the same as this one right here. Because at negative 10, negative 10 standard deviations away from the mean is like nothing. Like there's nothing there. If you're 10 standard deviations away from the mean, you are a miracle. You are Neo. You're the one, right? Yeah. Negative 10 is super accurate. As accurate as you're ever going to need. We'll work with it. So questions on this. This is the calculator portion. This is how you calculate these on your calculator. And if you needed to say, find something with two different standard deviations, like let's say this is, I needed to find between negative 0.8 and 2.1. If you're looking for this area beneath the curve right there, then you're just going to use this number as your lower and this number as your high, as your upper. So let's just do that real quick, right? Going back to second vars, normal CDF. I want my lower to be negative 0.8. Go away. What are you doing here? Negative 0.8. And my upper to be 2.1. 2.1. Paste it. Yep. And then 0.7702. This area in red right here is 0.7702. That's the percentile within that section of the normal model. Just for fun, just to test your ability to do it, can you guys please find the area? That's not a marker. Can you please find the area from negative 2 to 2? On your calculator there, be negative 2 to 2. And what should this be, by the way? What should the percentile be if we're going from negative 2 to 2? It should be 95%, right? So that's 68, 95, 99.7. What's that? What do we get? 0.9544 something something, right? Is it exactly 95%? No, this is why it's the general rule, okay? If we're looking for the exact z-score, it's actually closer to 1.96. If you go in your calculators now, do negative 1.96 to positive 1.96. So same thing, but do negative 1.96 to positive 1.96. When you get that, that should be a lot closer to 95. It should be like 0.9500 something. Yeah, 0004. So the 68, 95, 99.7 rule is a general rule, but it is definitely not exact. If we're looking for something closer to 95%, the z-score is actually closer to 1.96 than it is to 2. All right, so keep that in mind. Questions on the calculator portion here? Okay, well, why don't we do an example in context? Back on your notes, and then yeah. So let's back out of this. Let's get the right button here. Let's back out of this. We're still recording, right? Yep, good. We haven't broken anything yet. That. This. Got a couple buttons. So that's all in there. Good. That's the active sense. Okay, let's do an example. I believe this example is in your notes, right? It's about, should be about SAT scores. Yes? No? What? What happened? Do I have a cards example later? Nope. We'll tell you what. I'm going to do this example, and then you guys can do the cards example on your own. See, I did that on purpose. So the question is, what proportion of SAT scores fall between 450 and 600? Okay? We want to find the proportion of SAT scores that fall between 450 and 600. Where the mean is 500 and the standard deviation is 100. Before we do anything else, is it reasonable to assume that SAT scores are relatively normal? Maybe. Maybe with without a lot of foreknowledge about SAT scores. I will tell you, test scores in general tend to be rather normally distributed, especially when they involve cut scores, because we kind of tend to make them normally distributed. So it does work. It is normally distributed. Let's draw a picture first. So if the mean is at 500 and the standard deviation is 100, we'll just draw out my 3 standard deviations. This is 600, 700, 800, and then this is 400, 300, 200. So there's this normal model with a mean of 500 and a standard deviation of 100. We are looking for 450 to 600. So what section of the graph are we looking at? We're looking for from here to here. Right? That's the section. Oh gosh, what time are we at today? It's an early day, right? We got 5 minutes? Perfect, that's enough time. Sorry, just thought about it. So we have this little section right here. That's what we're looking for. So in order to use our calculator to find things, we cannot just throw 450 and 600 into our calculators. It won't do it for us that way. Before we can do anything else, we're going to need to calculate z-scores. So let's calculate the z-score for 450. 450 minus 500 over 100 gives me negative 0.5, right? 600, so we got 600 minus 500 divided by 100 should give us 1, right? That should make sense because 600 is 1 standard deviation away from it. So what we're going to type into our calculator then is the area between negative 0.5 and 1. So normal CDF from negative 0.5 to 1. Does somebody want out there want to do that for me since I don't have a calculator? What do you got, Hannah? 0.53. All right, we'll just call it 0.53. So that means that 53% of SAT scores fall between 450 and 600. And I think this is math SAT scores. Yes. You didn't do anything. You didn't do a thing. You didn't do a thing. Okay. Questions, comments, concerns on the example here? Not lying to you. You didn't do anything. Okay. Let's get homework out then. So this is going to be on page 132-ish, I think. This is on page 131. And I want you to do you're going to do 29 through 31. And then you're going to do 34 and 35. And then you're going to do 37 and 38. That's why I know a lot of teachers like they plan your homework beforehand. I always choose my questions on the spot. If it seems like I'm unprepared, it's because I am. No, I do it on purpose that way, so I don't assign you guys a ton of stuff that you don't know how to do. Everybody say bye, Brittany. Bye, Brittany.